All right, so it's kind of hard to word what's happening on number 5, but if you go back to the bottom and just think about what's happening, is either going to be a hole in the graph or it's going to be a vertical asymptote. So trying to remember stuff from algebra 2, what do you think is happening at -1? A hole or a vertical asymptote? That's a vertical asymptote. So you didn't graph rational functions last year, but you did vertical asymptotes when you graphed logarithmic functions. So it's a vertical line that the graph approaches but never quite gets there. And it's happening because this graph can't equal, or the x can't be -1. If x is -1, you get something like, I don't know, -16/0, and you can't divide by 0. So that's the reason why that's happening. Okay, and so on number 6, as x gets closer and closer to -1 on the left, what is happening to our function? It's decreasing faster and faster and faster. So it's actually approaching -infinity. And if you didn't write that, it's okay. If you wrote something, that was right. Now I'm going to show you guys a new limit notation that you've never seen before, and it's okay. We can figure this out together. But we're going to start with the limit, and we need to describe the limit as x approaches -1 from the left. So we would say x approaches -1. And to notate that we're only approaching from the left, you do another little negative that's kind of like an exponent, but it's a sign. It doesn't have a number, it's just a negative. So the limit as x approaches -1 from the left of g of x. And then the graph is approaching negative infinity, so it's equal to -infinity. So that's new notation for limit. So when the limit is approaching a number, you can sometimes just plug that number in for the x. In this case, you can't really because it gives you 16/0 or something. All right, so what is the graph approaching from the right? Good. All right, so we're going to use limit notation to write this also. So this time, the limit as x approaches -1. And then what do you think we do if it's from the right? A little plus. Good. And in this case, that is the graph is approaching positive. Okay, so we're going to practice that. Again, I don't expect you to completely understand it right now. All right, so what's happening on 8? What's happening at 3? There's a hole. Good. And the reason that happens is because if I put 3 in, I'm going to get something that's undefined. I actually get 0/0. So x can never be 3, so there's just like this empty space on our graph. That's a hole. Okay, and then if we get closer and closer to 3 from the left, what y is the graph getting closer and closer to? 2. All right, and we're going to use limit definition to write this also. So the limit as x approaches 3 from the left, so a little negative, of g of x is equal to 2. All right, what about from the right? It's still 2, right? Yeah. So if you guys decide to take calculus, you're going to be way ahead from where my pre-calculus students have ever been because they had never seen a limit. And you guys have already seen tons of limits. All right, so let's see about this conjecture. So what about the non-common zero from the denominator? What did that end up becoming? Vertical asymptote. And then the common zero ended up becoming a hole in the graph. All right, so I'm going to show you how to find those holes in the vertical asymptotes and what's happening without using a graph. So I'm not going to be able to depend on it every time. Okay, so anytime an x value is not in the domain of a rational function, then the graph is either going to have a hole there or the graph is going to have a vertical asymptote there. So domain is what we did yesterday. And then today we're going to decide like which one of those things it is and actually find the ordered pair of the hole. All right, and then we just wrote on the other sheet, but we'll go ahead and write it again here. So if you have a zero of the denominator, and if you just want to do d of x, you can, depending on what you understand. That is not in common with the numerator. Then that creates the vertical asymptote. So if we were using this kind of generic rational function here with a, b, and c, where would the vertical asymptote be? A, b, or c? B. Now, if we put b in for our function, because I already know it's a vertical asymptote, that's always going to give you a number over 0. And so that doesn't really tell you like what's happening at that vertical asymptote, like if it's approaching infinity or negative infinity. So what we're going to have to do is this right here. So we're going to plug in values that are close to the vertical asymptote on each side to kind of see if we're doing infinity or negative infinity. And the notation that we use is this limit notation that we wrote on the other paper too. But we'll do it with numbers and it's going to make more sense. All right, and then holes are going to be any zeros of the denominator that are in common with the numerator. That's going to create a hole in the graph. So you'll know automatically what the x part of the hole is. And then we have to do a little manipulating to find the y part. So if we were using this generic function here, would you have a hole at a, b, or c? C. And I know that if I did f of c and there's a hole in the graph, that's always going to give us 0 over 0. So we can't just plug it into the original. So we have to do this. We're going to plug it into a reduced version of the original. And so what I can do is, and we did this yesterday, we're going to continue doing it today, is just box those out because they're in common. And then you plug that c into the other parts of it. So in this case, what we're doing is we're finding the limit as x approaches c, and we plug it into c minus a, or we plug it in, it becomes c minus a over c minus b. And again, I think this is going to make a little more sense whenever it's numbers and not ABC. All right, So just like yesterday, the first thing you're going to do, if it's not already factored, is you're going to factor it. We need factored form to find asymptotes and holes. Or I should say vertical asymptotes and holes. If you are struggling with factoring, I would encourage you to get some extra help from me, from a tutor, from a friend. At this point, not that I don't expect you to factor perfectly every time, but I expect you to feel fairly comfortable with factoring where you don't just stare at it for 15 minutes and not know what to do. Whoops. All right. So do we need to box anything here? Yeah, we're going to box the x plus 4. All right, so A is asking us to find any vertical asymptotes. So are the vertical asymptotes going to come from inside the box or outside the box? Outside the box? Are they going to come from the top or from the bottom? Bottom. So what's our vertical asymptote going to be? 1. Because if x was 1, you're going to get some number over 0. All right. And then I'd say today, this part right here might be the most challenging part. So what we're going to do is describe the behavior on each side of the vertical asymptote. So because I know it's a vertical asymptote, I know that on each side it's either going to go towards infinity or negative infinity. So what I'm going to do is I'm going to plug in a number on the left side of 1, and I'm going to plug in a number on the right side of 1. And it needs to be pretty close to 1. So a number that's close to 1 on the left side is going to be a little bit smaller than 1, so I'm going to put in 0.9. And then on the right side of 1, it's a little bit bigger than 1, so I'm going to put in 1.1. All right. And I'm going to put this into the factored version. So this is a little bit of a repeat of what we did yesterday. All right, so I'm just putting in 0.9, doing the addition. Oh, let's fix this. This is wrong. All right, doing the addition or subtraction and just deciding if this is positive or if this is negative. All right, so when I take 0.9 and I add 4 to that, am I going to get a positive or am I going to get a negative? Yes. And when I take 0.9 and I subtract 4 from that, am I going to get a positive or a negative? Negative. All right, and then I'm adding 4 again. We technically, the ones that are common, we technically can just leave those out, but I'm just going to get nervous about telling you to leave out, and I'm afraid you're going to not know when to leave out and when to leave out. So we're just going to plug it in. All right, and then if I take 0.9 and I subtract 1 from it, what am I going to get? Negative. All right, and I'm just going to ignore the positives and count the negatives, and there's an even number of negatives, so that's going to be a positive. So what that means is the limit as x approaches 1 from the left of f of x is going to be positive infinity. So I know it's a vertical asymptote, so it's either going to be positive or negative infinity. I got a positive, so it means it's positive infinity. Okay, so let's go back and do the same thing with 1.1. So we're just adding 4, subtracting 4, subtracting 1. All right, and then I end up with an odd number of negatives, which means negative infinity for this vertical asymptote on the right side.
How'd you get negative?
The top left.
Right.
Okay, so I took 1.1 and I did 1.1 minus 4. Any other questions? All right, and then for C, I want to find the order pair of any hole in the graph. So does this one have a hole? Yes. So if you draw a box, there's a hole, and the hole is going to come from inside the box. So whatever makes that box 0 is the x part of the hole. So it's going to be -4. Right. And then to show your work, to find the y part of the hole, you're going to do the limit as x approaches that -4 of f of x. Now I cannot put it into the original equation because if I do, I'm going to get 0 over 0. So what I do is I plug it into what's not in the box. All right, so I just kind of ignore this for a second and put my -4 in for those x's. Now, a lot of times your hole is at a weird fraction, and that's fine. So I get -8 over -5, which I would definitely want to change that to a positive. So your hole is at 4, -4, sorry, 8/5. All right. Questions on those two things? Those are the two big things for today. All right, the next one we're going to do is already in factor form just to save some time. When you guys get your worksheet, some of them are already factored just because I want you to practice the new stuff more than just the factoring. But is this one going to have a vertical asymptote? What do you think? Well, first, do I need a box anything? No. So does this one have a vertical asymptote? Yes. And it's when x is -3. Good.
Wait, I have a question. So what if you had 2 parentheses on the bottom and all 4 of them were different?
Then you'd have 2 vertical asymptotes. Yeah, you can have multiple asymptotes and multiple holes. It's fine. Okay, so let's do our table so we can figure out the behavior on each side of the hole. So we want the left side of -3 and we want the right side of -3. This is a little tricky. If you're just kind of rushing and not thinking, you might get your left and right mixed up. So the left side of -3 is going to be a number smaller than -3 or more negative than -3. So what do y'all think? Yes, -3.1 is the left side of -3, and the right side of -3 is -2.9. So be careful with that. All right, so we're gonna plug in -3.1 and -2.9. So you guys try to do that on your own and figure out if we get positives or negatives, please. All right, so when you do the left side of -3, you get 3 negatives, which is gonna make the limit be -infinity. And the right side, you get 2 negatives, which is gonna make it positive infinity. All right, what questions do you guys have? Okay, on the back, we're going to do some of the stuff from yesterday and some of the stuff from today. All right, so let's just start off by factoring. So you guys factor that numerator and denominator on your own, please. Nope. Nope, the order, that doesn't matter. As long as your plus is with a 4, yeah. No. So the numbers do need to multiply to get 24, but they need to subtract to get 2. 8 and 3 gets you 5. All right, so what do we need to box up? X minus 6. All right, so there's two things that X cannot be, and what are they? Negative 6 and 6. So that means on your graph, you're either going to have a hole at one of those, or you're going to have vertical asymptote, or they could both be whatever. Okay, so going back to yesterday, we're going to give our X and our Y intercepts. So the x-intercept was going to come from the factored form. Are we going to do inside or outside of the box? Outside of the box, top or bottom? Top, good. So negative 4, 0 is going to be your x-intercept. All right, y-intercept, we don't need the factored version. We're just going to go back to the original and just kind of make all of our x's be zeros. And then I would want to reduce that. So it's definitely going to be a positive. What's the biggest number that goes into 24 and 36? 12. So it reduces down to 2/3. All right. So that was yesterday. And today we're going to start talking about holes and asymptotes. So with this one definitely has a hole. So anytime you box some factors, that creates a hole with whatever would make that box be 0 or 0 over 0. All right. And then to find the y part of the hole, we're going to do the limit as x approaches 6 of f of x, which means we're going to kick out the box and plug 6 into whatever is left. So kick out the box and then make all those x's 6's. And again, it's normal to get kind of a weird fraction. We get 10 over 12 or 5/6. So that's going to be the location of the hole in the graph. So when you're trying to find the vertical asymptote, you're going to look on the denominator outside of the box. If there's something there, then that is going to be a vertical asymptote. And I don't think I said this earlier, but the equation of a vertical line is always x equals a number. So your vertical asymptote should always be x equals a number. All right, and then we want to know what's happening, the behavior at the vertical asymptote. So we're going to want to see what's happening on the left side of negative 6 and on the right side of negative 6.
question.
Okay.
Why is it -6 and not -6?
It's going to be what's on the outside, and it's going to be whatever would make it 0.
Okay.
Okay, so when it's a negative, just take a second to think a little bit more about what's on the left and what's on the right, just to save yourself some time later. All right, so I'm going to take my factored form, and I'm just going to plug in -6.1 in. All right, so what questions do you guys have? Okay, so tomorrow we'll go back to those continuing examples and actually graph some holes and some vertical asymptotes so you can see what they look like. Yes.
Why is the right one on the top?
Right on the top.
Like, on -6.1, lean on the right. No, both of them.
Okay. Well, if you take -6.1 and you subtract 6 from it, that's -12.1. And that's the top and the bottom. Okay, so if you're having a hard time plugging these in your head, write it out. It's fine. But a negative minus another number is just going to make it more negative. All right. Any other questions? Oh, let me give you yours.